Okay, in this video we are going to look at the principle of conservation of momentum. So we are familiar with this equation from our previous videos. We find that force is equals to delta P over delta T, and if F equals to 0, then we get if F is equals to 0, then we get delta P equals to 0, which means that change in momentum is 0, which means there is no moment, there is no change, there is no change in momentum. All right. If we look at this common sense would tell us that if there is no forces applied, obviously momentum will not change. If momentum changes, then we need to apply the force, and if in case of no external force, the change in momentum is 0. Or in other words, whenever force is equal to 0, the momentum is conserved. This is known as the principle of conservation of momentum. I can write that in words in plain English. In the absence of net force, the momentum of an isolated system is conserved. All we are saying is that the momentum does not change, or in other words, P initial, P final is same as P initial. Yeah, which means that momentum is not changing. And mathematically, if you want to look at how we got this, it's commonsensically we got this delta P equals to 0, which means that P final minus P initial equals to 0, which means that P final is equals to P initial. Right? Now, this is an extremely important principle. Is observed everywhere without exception. Let's look at a problem in which we can use this to find the final velocity after collision. So the problem is like this, that we got an object of m1 here, we got another object m2 here. M1 is going like this. M1 mass is equals to 3 kilogram, and it is going to the right, or call it east direction, or to the right, with a velocity of 10 meter per second, and that's the second object is going towards the left. Its mass is equals to say 5 kilogram, and its velocity is equals to 9 meter per second. And they collide here, and after colliding they fuse together, so mass 1 and mass 2 combine together and it becomes a single mass now. All right, so our objective is to find the final velocity of this combined mass. Find the final velocity of the combined mass. Right? Now this is we can treat that as an isolated system. This is an isolated system on which no external force is acting. So therefore what it means is that total momentum before collision is equals to total momentum after collision. Okay, so all we need to do is we need to calculate the total momentum before collision and make it equal to total momentum after the collision, and that would help us find the velocity of the combined mass. So before collision, so let's say this is mass 1, so I will say P1 initial. That's I'm calling it P1 initial, means the initial momentum of object 1, and I'll write that as a vector is equals to m times v. So 3 times 10 meter per second, 3 kilogram times 10 times meter per second, and it is towards the right, so that becomes 30 Newton seconds towards the right. And because I'm taking it positive, it means the right and the right hand direction, the direction towards the right is my positive direction. P2i is the momentum of the second object, initial momentum of the second object. Here mass is equals to 5 and velocity is minus 9. We just need to keep into mind that this is going towards the left, and because the direction to the right was positive, so this we have to take as negative Newton second. So it's going like this. Because we got the negative, we don't need to show these arrows now, but I'm just showing this. That gives you minus 5 Newton second. So this is P1i is positive, P2i is negative. So total initial momentum is equals to P1i plus P2i, and because I took plus and minus, so direction is taken care of because this motion is in a single line. So that becomes 30 minus 45 is equals to minus 15 Newton second. And negative here means that this final momentum is towards the left because positive direction is to the right. And after collision, my mass is equals to is the combined mass now, which is basically 3 plus 5 is equals to 8 kilogram. And I need to find the velocity of this mass, so I can say the velocity of combined mass is equals to v. We call it v. So total final momentum is equals to m times v, which is equals to 8 v Newton second. Now, as per principle of conservation of momentum, and let me call it, this is my pf and this is pi. As per the principle of conservation of momentum, this total initial momentum should be equal to total final momentum. So I got pf, I can write here as per, let me clean that thing up, as per principle of conservation of momentum, I get pf is equals to pi, which means that 8v is equals to minus 15, and that will give you v is equals to minus 15 over 8 meter per second. The negative sign indicates that this velocity is in the negative direction, which means that after collision, when they fuse together, the combined mass would move towards the left with a velocity of 15.8 meter per second. If the objects are moving in one direction or opposite direction along a line, which is basically what we call as one-dimensional motion, it's a straightforward question, but you need to keep the direction in mind, and accordingly you need to have plus and minus. But if you have motion in 2 dimensions, then you will need to use vector addition and vector subtraction to solve these kind of questions.